Okay, in this video I am going to show you how to use Sage Math to plot the plane passing through a given point and perpendicular or normal to a given vector. So remember, the equation of such a plane is you take the normal vector and dot it with the difference between an arbitrary point P on the plane and that specific given point P sub 0, given in coordinates by x sub 0, y sub 0, z sub 0, and you dot that and set that equal to 0, because when you take the dot product and setting it equal to 0, that means the two vectors are perpendicular. And then if the normal vector n is given by ABC, expanding this out, you get this. Okay, so I'm going to call my plane, my function that I'm going to cook up, I'm going to call it my plane plot. And it's going to take as input the normal vector, the point P that the plane passes through, and C, a color. And what it will return is a 3D plot of the plane through P and perpendicular to N. Before we get into the code, let me just show you what the final result is going to be. Oops, so here's what here's one example, and then we can repeatedly call this function, and here's a couple example. The example of this function called a couple times. We can also zoom in, and I've also in these plots returned the normal vector, or shown the normal vector that was given as input, as well as the point. These normal vectors start at the point that was passed through to the function. Okay, so here's the code for the function, my plane plot. And so the first step is, well, as hopefully we know by now, to define a function, you start with def, and then you can enter whatever its name is, and then the input variables. In this case, n is going to be a vector, p is going to be a tuple, a 3-tuple, and c is going to be a color. Sage Math has its own color class or what have you. And then important is to have this colon after this. Don't forget that. Okay, so now we need to tell Sage that our variables are going to be x, y, and z. So that's what this line here says. Now I've commented out this second line beginning with f. That's what the hashtag in Sage and in Python refers to, is these lines are commented out. The reason I commented it out is, well, I actually wrote the program initially using this line. So let me explain what this commented line is. So f is going to be the equation of my plane, and what I'm going to be using is basically this form, this very last form down here of the equation. So n0, that's the 0th component of this vector n. Remember, in Sage and Python, we start counting from 0. So the first component a of n is n0, and then we multiply that by x minus x0. So here's where x minus, now our x0 is the first coordinate, well, yeah, the first coordinate of the point P, but in Python and Sage we refer to that as the 0th coordinate. And so that's what x minus p0 comes here. And then similarly, n1 times the second coordinate. Oh, and one important thing is you need to remember to put the asterisk. Otherwise, Sage doesn't understand it. Over here when we write math, there's no asterisk because, the multiplication is implicit. But in Sage, don't forget that. Okay, and then n2 times z minus p2 and so forth. Okay, so that's one thing. And then later on I realized that we can also use this dot product formula. I mean, again, they're all the same formulas. They're just, this last one is the expansion of the first one. So let me define g to be, basically it's the same as f, but just written a little bit differently. It's using this first formulation here. Okay, so n is our vector, and any vector has a dot product method built into Sage, so that's what dot underscore product is. And then we have to enter this x minus p. Maybe I've done it a little differently here. So I've taken this triple xyz, my triple of variables, and I need to turn it into a vector. If I just write xyz without this vector, Sage thinks it's a 3-tuple, which is a different type of object in Sage than a vector. In math, a 3-tuple and a vector, they're the same thing, a 3-dimensional vector, but in Sage they're different. So that's why we have to put vector, and then importantly is you need double parentheses, because the first parentheses refers to what you're throwing into the vector function, and then you need to throw in a tuple itself into the vector function. That's why you need double parentheses. I've repeatedly forgot the double parentheses and only inserted a single parentheses and got lots of unintelligible errors, and I didn't realize that that was the problem until after quite a while. Okay, and then similarly here, P is a tuple, a point, like 1, 2, 3, but Sage has, the way we pass this in, hasn't converted it to a vector, so we need to tell Sage we treat this as a vector. And the benefit of doing so is Sage knows how to subtract 2 vectors. It doesn't know how to subtract 2 tuples, even though maybe it should. But, okay. All right, so now finally we get to the plotting function. So P is going to stand for the plot, and the function is implicit underscore plot. That's the built-in function into Sage, and with a 3D, since we want to plot a 3D. If you just want 2D, it's implicit underscore plot, just that. But with 3D, we want the 3D here, and then the function we want to plot is this g, and then set it equal to 0. Again, it's important to have the double equal sign, because that's the comparison operator in computer science, in pretty much any language. And so this is saying we're going to plot a point xyz if the value of g evaluated at that point xyz equals 0. So again, it's important to have this double equal signs. Okay, so then we give in the range that x should take values in. So x should go from -20 to 20. I again just made these numbers up. You can change them later. Y goes from -20 to 20. Z goes from -20 to 20. Okay, fine. And then this implicit plot 3D accepts a color attribute or keyword, and I'm just going to say the color is equal to the color we passed into it. Like it could be blue, light pink, I think is an acceptable color, aqua. So there's various names of colors, and you can also pass in the RGB triple and so on, as I'll explain later. Okay, so then that's going to be our first part of the plot. And then what I also want to add in to the plot, so P is our plot, and then so it's something is plotted, well, and then I want to add to the plot. What do I want to add? I want to add the point P that we, uppercase P that we gave as input, and then I want to color that red. And then I also want to add to that plot the vector n, the normal vector n, and when you plot a vector, it'll start at the origin when you plot it, as we typically give a vector as a 3-tuple, and that implicitly means that the vector as an arrow starts at the origin and ends at that 3-tuple. But let me just go down here to illustrate what I'm talking about. Here, I want the normal vector n to start at the point that we gave as input. And so here's some other examples. And not start at the origin. And so in order to do that, I want to enter this part here, that start the arrow, this vector n at P. If you leave this out, it'll start the vector at the origin. Okay, and then I just decided to color it red. Okay, and so now, and let me also explain this plus equals. If you're familiar with, like, for example, C++, this is shorthand for P is equal to P plus whatever follows. So I could have used that above in the line above as well, but I decided to do it the long way. P is equal to P plus. So you have this plot P in the first line, that's some sort of picture, and then you add to that a point n, plotting the point n, and then we also add to that this vector n. Okay, and then finally what we return is lowercase p, which again is a plot. The type of, if you ask what is the type stored in Sage Math of the object lowercase p, it's some sort of three-dimensional graphics object. Okay, so that's the function that I'm defining, and now let's call it or try it out. So instead of calling the vector n, I'm going to just change the name to m. So that's going to be a normal vector, and I decided some normal vector like 5, 1, 2. And once again, don't forget the double parentheses. Vector 5, 1, 2 with single parentheses, that will return an unintelligible error. So it's something like you can't iteratively call something, or I don't remember what, but it's unintelligible what the error is trying to say. Okay, and then what will also work though is vector with square brackets 5, 1, 2. That will, I think, give the exact same thing as round parentheses 5, 1, 2. Okay, so that's our vector m, and then I need a point, so I'm going to just call it q instead of my point capital P, just for no particular reason. And I'm going to call this point, I just chose a random point, 1, 2, 1. And because I want to apply the function again to a different point, later on I'll throw in another point r, 9, 3, 4. Okay, and these are tuples, q and r. They're not vectors. So when I ask Sage what type of object they are, m is of type basically vector, and q is of type tuple. And then, even though m and q, they look like just a triple of numbers each, but they behave very differently internally in Sage. So for example, if I do 2 times m, the scalar 2 times the vector m, so again, m was 5, 1, 2, then each entry of a vector gets doubled. That's how scalar multiplication behaves. And so we get 10, 2, 4. But surprisingly, I was surprised to see this, when I did 2 times q, it just doubled. The 1 to 1 turned into 1 to 1 repeated. So that's, I learned that while making this video. Okay, now that we've got our vector v and our point, our vector m, our point q, and now let me just pass in a color blue, say, and now I'm going to make the, well, here's what it returned. So here's our vector, here's our plane passing through this particular point, and you can see that the coordinates are, the coordinate axes start from -20 to 20, and you can move this around. Okay, let's do another call to the function. Oh, let me just say a little bit about colors. So colors are stored, well, there's some names for colors, like you can look these up, like light pink, and in Sage they're stored as a triple of numbers between 0 and 1. So this is the RGB triple associated to light pink, 1.7.7. Sometimes you'll see triples with numbers ranging from 0 to 255 or something. In that case, just divide all those numbers, those 3 numbers, by 255, and then you'll get the numbers between 0 and 1. Okay, so now I want to call my plane plot function twice. So notice this plus sign. I'm going to be combining the plots. That's what the plus sign does. If you have 2 plots and you put a plus sign between them, it'll plot both outputs on the same plot. Okay, so now I'm going to plot this point q, plot this plane that passes through q, and just to make this, the vector that's appearing, the normal vector, appear bigger, I'm going to throw in -7 times m. Okay, so that's in Aqua, and then I'm calling this another plane plot, my plane plot, and 7 times some other random vector that I just cooked up to this point r, and then here I want to just show you how to refer to this color as the RGB triple. So 1.7, 1.75, I've just truncated these numbers, and of course you can just type in any numbers between 0 and 1 and it'll give some random color. Okay, so yeah, that's what I guess I wanted to say. And you can kind of see that these 2 planes, they intersect in a line. Okay,